Hello there, you're welcome to my YouTube channel. In this video, I'm going to be talking about binary operations. As you can see before us, we have this question which says, an operation, this asterisk, is defined on the set of real numbers R by this x asterisk y is equal to x plus y plus 3xy. If the asterisk, which is the operation, is commutative, when they say commutative, they mean that you can change the position of the element. Maybe, for example, you have 2 plus 5. You know that 2 plus 5 is also 5 plus 2. So you can say 5 and 2, they are commutative under the operation plus. The same thing too for multiplication. 2 times 5 is also equal to 5 times 2. They will both be 10. Now, let's read on. We're asked to find the identity element of R under the operation asterisk. Now, before you can even solve this question or attempt the first question, you must understand what it is when they say identity element. Now, what is an identity element? An identity element is an element when applied to another element has no effect on that element. It has no impact on another element. For example, let's say you have under multiplication, for instance, let's start with multiplication. If you have 5 times 1, you know, this is the operation times. 5 times 1 is also 5. 7 times 1 is also what? 7. Can you see that when 5 gets multiplied by 1, we have 5. And when 7 gets multiplied by 1, we get 7. So it means that 1 is the identity element. Since when it is applied to 5, we got 5 back. You see, nothing was changed. 5 remained the same and 7 remained the same. You understand? So 1 is an identity element under multiplication. Now, what about addition? Let me just quickly talk more about addition. Can you tell me the number when added to another number will give me the same number? 0, because when you do 5 plus 0, you get 5, right? And when you also do 7 plus 0, you get 7. So it means that 0 is the identity element under addition here, because 5 remained the same, 7 remained the same. There was no change at all. For multiplication, 1 is the identity element. For addition, 0 is the identity element. Now that we know what identity element is, it will now help us in solving the question. Now, before I even go back to the first question, which is for us to get the identity element, let me also paint a picture of what it looks when you hear identity element. Take, for instance, you hold the mirror and you put the mirror to your face. Who are you going to see? Of course, you will see yourself. So, which means that that mirror is acting in the capacity of an identity element. It produced your face back as the image being reflected. So that is what it is when you hear about identity element. It's an element when applied to another element produces the same result. So let's go to the first question. The first question here says we should find the identity element of R under this operation. Okay, but let's go back to the original question. It says that this operation is defined on the set of real numbers R by x asterisk y is equal to what? Let's see how the operation is being defined. X plus y plus 3xy. So let's go get the identity element. X asterisk y is equal to what? X plus y plus 3xy. Remember, I said if you apply the identity element to an element, it produces the same result. If that is the case, let's now take our identity element. We're going to use E to represent the identity element. You can use I. So X asterisk, which is the operation, E. E is the identity element. Remember what we said about identity element. It will produce the same result. So let this be equal to, I am not going to write this now, but I will replace Y and put E. So I will no longer write Y, I will now write E. So that will be what? X plus no longer y but e, because I am combining x and the identity element e. Then plus 3xe. Can you see that? Now it will be okay if we equate all of these, because I told you now that if you apply an identity element to an element, you will get back the element. All of these will be equal to what? X. For the singular reason that when you apply an identity element to an element, it will produce the same element. So see what we have now, and the result is what? X. I'm now going to solve this and make E the subject of the formula, since E is the identity element. Now let's simplify this. I'm going to move this X to the right hand side. So let me just write this as X plus E plus 3xe is equal to X. Now let's transpose X to the right hand side. I'm going to have E plus 3xe is equal to X minus X. And of course, X minus X is 0. I'm going to factorize E, then bracket. What is E into E? That's 1 plus, what is E into 3xe? That is 3x. Close the bracket, is equal to X minus X is 0. Now, I'm going to divide both sides by what? 1 plus 3x. So let's do that here and here as well. So this cancels this, and E is equal to 0 divided by 1 plus 3x is 0. So what does this tell you? That the identity element is 0 under the operation. We have gotten the identity element. Let's get the inverse element. Let's go back to the question. The second question says, let's determine the inverse of the element under the operation. So, first of all, what is an inverse element? An inverse element is an element when applied to another element produces an identity element. It produces an identity element. Let's still go back to the operation multiplication again. If I decide to write 5 and I want to get the inverse of 5, remember, for inverse element, if you apply an inverse element to an element, the result will be an identity element. Remember what we said the identity element is under multiplication, it is 1. So when you apply the inverse of 5 under multiplication is 1 over 5. Now, if you divide this, what are you going to get? 1. 1 is an identity element. So which means if you apply an inverse element to an element, the result that you will get will be an identity element. Let's pick another example. 9 times 1 over 9. If you divide this, you are going to get what? 1. So you see, we get back the identity element. What about for addition? Let's look at the inverse under addition. What did I say the identity element is under addition again? It was 0, right? Now, which means if I apply the inverse to a number, say 5, I must get 0 as the result. And when I do this, the inverse of 5 under addition will be negative 5. Because 5 plus negative 5 is equal to 0. This 0 here is the identity element, and negative 5 is the inverse of 5 under addition. So this is what inverse element is. Now that we have explained what inverse elements do, let's now attempt the second question, which is for us to get the inverse element. Okay, so the second part. Remember, we have the same element x, operation. Let me just write the operation again. X operation y is equal to what? X plus y plus 3xy. Very good. Now let's introduce our inverse element. I'm going to use x raised to the power negative 1 to represent the inverse element. This is equal to x plus. Now this inverse is going to replace y. So that will be what? X inverse plus 3x x inverse. Again, our goal is to get the inverse element. What did I tell you about inverse element? What do they do? When you apply an inverse element to an element, the result you will get will be an identity element. And we've already gotten our identity element as what? 0. That is what we're going to use. Come back to A again. What was our identity element? See it here, 0. We're going to use this identity element to get our inverse element. So the result of this now will be equal to what? 0. 0 is the identity element. So I'm going to work this out and let's get the inverse element. So I'll transpose, or let me just rewrite this first. X plus x inverse, then plus 3x x inverse is equal to 0. Let's move x to the right hand side. We have x inverse plus 3x x inverse is equal to negative x. Let us factorize. 6x inverse is common, so I am going to factor it out, and I will have what? 1, because x inverse into x inverse is 1, plus x inverse goes into this, you have what? 3x. And all of this is equal to negative x. If you divide both sides by 1 plus 3x, our inverse element will be equal to what? Negative x over 1 plus 3x. So you can see that this is the inverse of the element. The last question, let's go back to the question. So this last one says, find the value x under the operation for which no inverse exists. No inverse exists. If we say no inverse exists, let's go back to the inverse that we got earlier. For this inverse not to exist, remember the inverse is equal to negative x over 1 plus 3x. For this inverse not to exist, then this must be undefined. What will make this rational expression undefined? It's going to be undefined if the denominator is set to 0. So we are going to get the value of x for which this inverse will not exist. So what I'm going to write will be that 1 plus 3x, which is the denominator, because if you have, see, look at this negative x over 1 plus 3x. If we set 1 plus 3x to be equal to 0, negative x over 0 is undefined. So when the denominator is set to 0, the inverse will cease to exist. That's what I'm going to write out. Now I'm going to write that 1 plus 3x is equal to 0. And I will get the value of x. So let's transpose 1 to the right hand side to be 3x is equal to negative 1. And when I divide both sides by 3, I'm going to have that x is equal to negative 1 over 3. So when x is equal to negative 1 over 3, the inverse will not exist. I hope you got value from this video. If you enjoyed this video, please kindly support my work by subscribing to this channel and share this video to your friends and family. I will see you in the next one. It's bye for now.